lava is made up of blocks. There's bits that are a little denser than others, and you can see there's a lot of different pieces to it. So we call this a blocky lava flow.
This blocky lava provides a crucial clue as to why the Ring of Fire volcanoes can be so deadly.
This lava is more thick when it comes out of the volcano, and its thickness will have an effect on how it runs down the slope. The thickness or viscosity of lavas can be shown in a number of ways. Hawaii lavas are quite runny. Honey is a perfect example of that. If you have the volcano putting out Hawaii-like lava, it's going to run quite easily down the rock. Whereas if you have something more like these blocky lavas, they're going to be a little bit more like peanut butter. They'll still run, but the viscosity is much greater.
The viscosity of lava is primarily determined by the amount of silica it contains. Silica is the most abundant mineral in Earth's crust.
The more silica, the thicker or more viscous a lava is likely to be.
Hawaiian lava contains little silica, so it's runny and produces a relatively flat landscape. But Ring of Fire lavas are rich in silica, making them sticky and less able to flow, creating tall, cone-shaped stratovolcanoes. During the 2006 eruption of Augustine, thermal imaging cameras were used to study the volcano. They showed this sticky lava building up layer upon layer. But the thickness of this lava also makes these volcanoes lethal.
Because these volcanoes have lava that is thick, things don't move through them very well. And bubbles of gases can build up.
Deep in the earth, under immense pressure, molten rock called magma contains dissolved gas. But as this magma rises, the pressure decreases. This drop in pressure means bubbles of the gas begin to appear, just like opening a bottle of soda. If the magma is runny, these gases can safely escape. But in sticky, silica-rich Ring of Fire magma, the gases can get trapped, often with terrible consequences.
It's like trying to have a bubble move through peanut butter. It won't happen quite so easily. So there's a lot of pressure that builds up. And once that pressure builds up, it reaches a point where it can't take all that pressure anymore.
The result? Giant explosions caused by the catastrophic buildup of gas inside the molten rock. This is the reason Ring of Fire volcanoes can be so dangerous. But it's not usually the initial explosion that kills. It's what happens next.
Those explosive eruptions can create plumes that go up for tens of miles.
When these plumes run out of energy, they can collapse back down the sides of the volcano in a superheated avalanche of ash and gas. With temperatures of 1,300 degrees Fahrenheit and speeds over 100 miles per hour, these flows destroy everything in their path. A terrifying consequence of the explosive eruptions caused by gases building up inside thick lava.